Assalamualaikum and a very good day to everyone. Today, our group is going to present our project, a concert ticketing management system. Now, I will introduce our group members. First, we have Duratul Najiha who serves as our project manager. Next is Nur Khalisa as our programmer. And finally, myself, Nur Najiha, acting as the software engineer. Now, let's look at the background of our project. First, the problem. Right now, manual tracking by event organizers causes a lot of issues like double book seat and slow payment updates. Customers also find it hard to check if tickets are still available and want a faster way to pay online. Next, the solution. Our system makes this process easy and fast by letting customers search for their favorite concerts, book seats instantly, and make secure online payments. Finally, our ultimate goals is to provide a smooth, reliable ticketing experience so that booking is more efficient for everyone and no fan miss out on their favorite
Now, I will
shows.
explain the objective of our concert ticket management system. The first objective is to calculate the total price of ticket based on the seat category and quantity selected by the customer. This feature helps users know the exact amount they need to pay according to their ticket choices. The second objective is to sort concerts by date. This allows users to view concerts in an organized manner and make it easier for them to find upcoming events. The third objective is to search for a ticket using its ID and update its status. Through this function, user can quickly locate ticket information and manage ticket records efficiently. The fourth objective is to count the available seats for each concert. This helps monitor seat availability and ensure that ticket sales are managed accurately without exceeding the venue capacity. In summary, these objectives are designed to make the concert ticket management process more efficient, organized, and user-friendly for customers.
Next, we're moving to use case diagram, where it shows how customers interact with concert ticketing management system. We've got 5 main functions here and have include and extend, where include is mandatory and extend is optional or a conditional step. The first function is login, where the customer can log in into the system, and it includes verify password and also extend to display login error if login is failed. The second one is search concert. The third one is book concert, where we can include check ability and extend the cancel ticket. The fourth one is make payment, where it includes validate the payment, and the last one is print receipt, where the customer can print the receipt of the payment. Here is UML class diagram, where it shows the main object of the concert ticketing system. We got customer, concert, booking, payment, and authentication. And it shows how they interact to allow customer to book concert ticket and make payment. As you can see here, customer and authentication using a relationship association. Association is where the classes can exist independently. Same goes with concert and customer and booking, booking and payment, and also lastly payment and receipt. But it's quite different with concert and booking, where the relationship is composition. Composition is where one classes can exist without one the other.
Today, I will explain the user class in our program. This class is designed to represent a user in the system and store important user information. The class contains 4 private attributes, which are user ID, name, username, and password. These attributes are declared as private to ensure data encapsulation and prevent direct access from outside the class. Next, we have 2 constructors. The first one is the default constructor, which initializes all attributes with empty strings. The second constructor is normal constructor that allows values to be assigned to all attributes when a user object is created. Includes getter methods, namely get user ID, get name, get username, and get password. These methods are used to retrieve the values of attributes. In addition, there are setter methods such as set user ID, set name, set username, and set password, which allow the attributes values to be modified when necessary. Another important method in this class is check login. This method accepts a username and password entered by the user and compares them with the stored username and password. If both values match, the method returns true, indicating a successful login. Otherwise, it returns fails. Finally, the true string method is used to display the username information into a readable format. The password is not displayed for security purpose. In conclusion, the user class demonstrates the object-oriented programming concept of encapsulation, constructor, accessor, and member methods, as well as basic user authentication through the chat login method.
Hi, today I'm going to explain the booking class, where we can see the attribute. The attributes are declared to private to protect the data and support encapsulation. The declaration customer, concert, and ticket are object references that allow the booking class to store and interact with customer, concert, and ticket objects. This design promotes code reusability. Next, we're going to go to default constructor. This constructor creates an empty booking object with default value, and as you can see here, there is this .ticket equal to new economy ticket, where the economy ticket itself is a subclass from the ticket class, where it applies inheritance and polymorphism. Next, we're going to go to normal constructor, where this constructor creates a booking with actual booking information. We're moving to the next slide. Here we can see getter method. Getter method allows access to private attribute. This method also provides control access to booking information without exposing the actual variables. Next, we can see setter method here. Setter method allows updating attribute values. It also helps maintaining encapsulation by modifying attribute through method instead of direct access. Another method that we can see in this slide is get total price. This method calculates and returns the total ticket price by calling the calculate price method from the ticket class. And as you can see here, we clearly use polymorphism because ticket.calculate price run differently depending on whether the object is VIP ticket, regular ticket, or economy ticket. In this slide, we're going to see a method called create booking. In this method, we're going to process a booking request where we can check whether enough seats are available using concert.check availability. And if seats are available, we're going to reduce the available seat and change the status into book. And they're also going to display a successful message. Otherwise, the status is going to change into fail and display a failure message. This method ensures that bookings can only be made when sufficient seats are exist. Okay, below the create booking method, we can see another method called cancel booking. This method cancel an existing booking. How? We're going to check if the booking status is booked or paid. If valid, they're going to return the book seat to the concert. And then they're going to change the update status into cancel and display a cancellation message. Otherwise, an error message going to be displayed. Okay, this helps maintaining accurate seat availability. Okay, in this slide, we got three methods. The first method called update status, where we can update the booking status manually. Second one, get booking details. This method displays all booking information by calling the toString method. And the third one is toString method. This method returns a formatted string containing complete booking details, and it's going to be displayed in a readable format. So it's easier for us to be read.
Now, I will explain the receipt class. To start off, let's look at the foundation of our receipt class. At the very top, we have our imports for print writer and file not found exception because this class handles exporting files. Moving down to the attributes, you will see we are using object composition by including a booking object and a payment object directly inside the class. Below that, we have two constructors, a default one to initialize empty values and a normal constructor that maps our data and automatically sets the total amount based on the payment details. Moving on to the next section, we have our standard getters and setters. This provides safe, controlled access to our private data. One quick thing to note here is inside set payment, whenever a payment is updated, the system automatically recalibrates and updates the total amount filled to ensure our financial data stays synchronized and accurate. Now, we have two methods here, generate receipt and print receipt. Both of these rely on a simple if-else conditional check. They look at the payment status, and a receipt will only process or print if that status is explicitly marked as successful. If the payment failed or is pending, the system safely blocks the action and prints an error message. Finally, we have our file operation and layout formatting. The save receipt to file method uses a try-catch block to safely write a physical text file to the system, dynamically naming it using the unique booking ID so files don't overwrite each other. Right below that is our toString method. This handles the actual visual layout, pulling pieces of data from our booking, concert, and customer objects to print out a clean, structured receipt for the user.